On completing this chapter, you will have an understanding of why the startup stage is extremely critical, how the proven pressure capacity of the pumps, valves and line systems is important when discharging at full rate, the aims of the ballasting stage, the main aims and concerns of crude oil washing, why ship's trim and the discharge pressure of cargo pumps is important during stripping, the key features of the 3 cargo stripping systems and their use, why pressing up of ballast tanks is important before departure, the ship's main concern during the final gauging of cargo tanks after discharge, the importance of the final line clearing of the cargo hose. In the startup phase of the discharge operations, what extremely critical measures ensure that tank's atmosphere does not go into negative pressure and that any leaks into dry pipes and valves are quickly detected? The discharge operation normally commences according to the following procedure. Formalities with port authorities and terminal, loading master, completed. Cargo hoses, arms, well connected. Cargo surveyors, completed tank survey and calculation of the cargo arrival figures. Lining up of lines, valves and pumps to be used, both onshore and on board, under the supervision of the chief officer and loading master. Line up and start inert gas plant, with the recirculation valve returning gas to the funnel until the pumps start running. When lining up is completed, and it is confirmed the inert gas plant is running satisfactorily, the chief officer reports to the loading master that the vessel is ready to start pumping. The loading master orders the vessel's manifold valves to be opened according to the agreed discharge plan. When the manifold valves are confirmed open, the loading master orders discharge to commence at slow rate for line displacement. The cargo pump or pumps are now being started, either by the chief officer, pumpman or duty deck officer, in close cooperation with the duty engineer in the engine control room, at slow rate until correct flow is confirmed. When the cargo pump or pumps are running, the inert gas is opened to the deck lines. The duty deck officer, pumpman and boatswain with deck crew must, during this sequence, check that the cargo oil is passing through the manifolds and check valves and lines in use to ensure that no malfunction or leaks occur when the cargo oil enters. Once all lines and valve settings have been proved to be free of leaks and the discharge operations have stabilized at a low rate, what is the main risk when pump revolutions are raised to the full discharge rate? When the loading master confirms that the oil flow is as planned and that the line displacement is completed, he instructs the vessel to slowly increase the discharge rate to the maximum as agreed upon in the discharge plan. In order to utilize the cargo pump's capacity and operate them correctly, either in series or in parallel, it is important to understand the pump's characteristics and know the shore lines and reception facility. At this stage, as the discharge has reached the maximum agreed capacity, it is important to check the pumps and cargo lines in order to discover any leaks caused by damaged flange gaskets or pipes holed due to corrosion or pitting. For further information on operation of cargo pumps, see CBT number 0078. What are the 4 main aims of taking in water ballast considered in the discharge plan, which decide when to start taking in ballast during discharging? When to start taking on ballast depends on the discharge rate, hull stress, air draft or freeboard or limitations on fixed discharge arms on the terminal, trim requirements for stripping, and also often a terminal requirement that the vessel may leave the berth immediately in an emergency. This was considered in the ship-shore meeting and will be found in the discharge plan. In order to save fuel cost, taking on ballast by gravity in the first few hours of the ballasting operation may be considered. Ballast in the double-hull ballast tanks is completely segregated from the cargo tanks and piping, and is therefore ideal for adjusting the trim in connection with crude oil washing and final stripping of cargo tanks. All ballast handling is required to be recorded in the vessel's Ballast Water Management Plan, according to IMO Resolution A868-20 Convention adopted June 2010. What are the 6 main aims and concerns in a crude oil washing operation? The crude oil washing operation is a demanding task that requires full attention from all duty deck personnel. The terminal requires to be informed when crude oil washing starts and to be updated during the operation and when completed. Before departure on a ballast voyage, after the complete discharge of cargo, sufficient tanks shall have been crude oil washed in accordance with the procedures specified in the Crude Oil Washing Operations and Equipment Manual. Designated heavy weather ballast tank, cleaned to take on ballast in bad weather. For the new double-hull tankers, the required number of tanks to be crude oil washed every discharge are approximately 1/4 of the total number of tanks, including the tanks which are dedicated to take on heavy weather ballast. The remaining tanks to be crude oil washed on a rotation basis. Sludge control routines. For sludge control purposes, no tank needs to be crude oil washed more than once in every 4 months. Static electricity. To avoid excessive electrostatic generation in the washing process due to the presence of water in the crude oil washing fluid, the contents of any tank to be used as a source of crude oil washing fluid must first be discharged by at least 1 meter before being so used. Any tank used as a slop tank on the previous ballast voyage shall be completely discharged and refilled with dry crude oil if that tank is to be used as a source of washing fluid. Vapor generation and VOC emission. In order to minimize the vaporization of volatile organic compounds while crude oil washing, closed-cycle washing from a dedicated slop tank reusing a fixed quantity of oil is preferable to bleeding off fresh crude oil from a tank during its discharge. Inert gas pressure and oxygen content. Before starting crude oil washing, it is required to measure the tank atmosphere to ensure that oxygen content does not exceed 8%, and that the oxygen content in the inert gas supply does not exceed 5%. Throughout the entire discharge and crude oil washing operation, it is important to monitor the inert gas pressure. If the inert gas system fails, the discharge and crude oil washing operation must be stopped and cannot be resumed until the inert gas system is working satisfactorily again. All crude oil washing machines need to be regularly function checked during the operation, and necessary adjustment of the drive unit program for correct washing pattern and cycles are to be carried out according to the discharge plan. Effective stripping throughout. Finally, the sludge sediment at the bottom is effectively removed, only if it is stripped out immediately and not allowed to accumulate. The crude oil washing requirements of MARPOL Annex 1 are comprehensive and covers detailed technical and design criteria, minimum coverage of area to be washed, capacity of supply pumps, as well as stripping plant. The STCW code defines special competence levels for personnel responsible and involved in crude oil washing operations. For detailed information on crude oil washing, see CBT number 0054. How does a good trim by the stern help in the stripping of cargo tanks? And how can a duty officer tell when a cargo pump's efficiency is dropping due to gas accumulation and the vacuum stripping system is to be started? The stripping, or final draining of the cargo tanks, is an important phase of the discharge operation. In order to achieve a satisfactory out-turn of the cargo, it is necessary to document that the remaining quantity in the cargo tanks, lines and pumps are as close to zero as possible. Prior to reaching the stripping level in the cargo tanks, the vessel should be trimmed to a certain trim on the stern in order to obtain a natural free liquid flow to the suction area in the after part of the tanks. By observing the cargo pump pressure gauges, the duty deck officer or pumpman who is operating the cargo pump console will get an indication by falling pumping pressure that the pump or pump's efficiency are dropping because of gas accumulation. At this stage, it is necessary to assist the pump or pumps by starting the vacuum strip system. What are the three main cargo stripping systems in use on crude oil tankers? On crude oil carriers, there are three different draining and stripping systems fitted. The vacuum strip system, the stripping eductor, and the stripping pump for line stripping through the small diameter line or marpole line. Click on the buttons to learn more. Vacuum stripping system. Where does the gas removed by the vacuum pump from the separator tanks of the cargo pumps get discharged to? What prevents the oil in the separator tank from being vacuumed out together with the gas? The vacuum strip composition is a system which is fitted on the suction line and close to each cargo pump. The system consists of a separator tank forming part of the suction line to each cargo pump. The purpose of this separator tank is to support the cargo pump with liquid. The separator tank, one for each cargo pump, has a pipe connection to a vacuum tank located at a higher level in the pump room. Further, the vacuum tank is connected to a vacuum pump. Briefly explained, the liquid level inside the separator tank will fall when the liquid level in the cargo tank becomes lower than the height of the separator tank, and the void space above the liquid inside the separator tank will increase. At this stage, falling pump pressure should be observed, and the vacuum system started. At a fixed liquid level in the separator tank, a signal is given to the vacuum pump to start, and vacuum is created in the vacuum tank. The valve opens between the vacuum tank and the top of the separator tank, and by that, the vacuum effect in the void space on top of the liquid level inside the separator tank will lift the liquid level and assist the cargo pump. The gas accumulation on top of the liquid inside the separator tank will at the same time be evacuated by a separate line into the slop tank. As the oil level in the separator rises to a cut-off point, a signal shuts off the valve connecting to the vacuum tank, and liquid cargo is prevented from being vacuumed up. Assisted by the vacuum strip system, the cargo tanks can be satisfactorily emptied by the cargo pumps. In addition, the suction area for the stripping suction bell mouth on the double-hull tankers is formed as a sump called the suction well, which allows the suction bell mouth to be fixed inside a restricted area and lower than the tank bottom. For further details regarding vacuum strip systems, see separate documentation. The stripping eductor. Why is the stripping eductor specially preferred for draining tanks during crude oil washing? During crude oil washing, the washing fluid is discharged to shore with the bulk cargo. In the final stage of the crude oil washing, bottom crude oil washing for removal of sludge and sediments, the stripping eductor is used, as well as for final draining of all cargo tank bottoms and lines. The stripping eductor is driven by either a cargo pump or a separate crude oil washing pump. The driving fluid and the drainage from the tanks are delivered into the primary slop tank. The slop tank will then be the last tank to discharge with one cargo pump. The stripping eductor is designed to a capacity 1.25 times higher than the combined throughput of all crude oil washing machines designed to be used simultaneously. That is why it is preferred for stripping during crude oil washing. Another reason is that it creates a vacuum continuously for fluid as well as gas directly in the cargo tank, if the tank becomes dry temporarily and gas pockets form in the suction pipe. A stripping pump would stop and start, and a vac strip pump would need a good quantity of oil in the pipe. When the crude oil washing is completed, the after crude oil washing checklist is to be completed. When finally stripping the main cargo lines, Why should inert gas be allowed to enter from a cargo tank at the highest point of the manifold? When the slop tanks are empty, the bulk discharge is completed and the manifold valves are to be closed. The final draining of the vessel's cargo pumps and lines in the pump room and on deck shall be carried out by means of a stripping pump, normally a steam-driven pump, which can deliver the remaining oil to shore through a small diameter line, also called a marpole line. This line is connected to one of the manifold lines and outside of the manifold gate valve in order to enable direct discharge to shore after the manifold valves have been closed. When the final draining through the small diameter line is completed and its valve at the manifold is closed, the remainder in the same line is dropped via a small branch pipe to the nearest cargo tank. The discharging operation is completed. When draining the main cargo lines, it is important to break the vacuum caused at the top of the manifold by the stripping pump taking suction at the lowest point of the pipelines. For this purpose, a 2-inch line with a gooseneck is provided from the highest point of the manifold to the inert atmosphere at the top of a cargo tank. The valve in the line should be opened to break the vacuum during final line stripping. Give 2 reasons why ballast tanks should be filled to the maximum level possible before sailing out. The forward ballast tanks will normally remain to be topped up when the discharge operation is completed, as these tanks may have been used for trimming the vessel by stern for cargo stripping. The ballast tanks should always be filled to the maximum allowance in order to minimize the void space between the ballast water and deck. From experience, it is well known that this area in the ballast tanks is exposed to air and splash of seawater, which results in corrosion. This also helps to minimize free surface effects due to slack ballast tanks. When the last ballast tank is topped up, the vessel should be in a seaworthy condition, as prescribed by the IMO or SOLAS regulations. The ballast operation is now to be recorded in the Ballast Water Management Plan. What is the ship's major commercial concern when the tank is being finally surveyed on completion of discharge? As soon as the discharge is completed, the cargo surveyors start surveying the cargo tanks together with the duty deck officer and deck crew. This survey consists of dipping the tanks in order to confirm that all cargo is discharged. All tank dipping must be through dipping pipes or hatches with vapor locks. After completion of the tank survey, surveyors calculate the remaining on-board quantity, and all documentation is signed by the chief officer and cargo surveyor. If an unacceptable quantity of the cargo oil remains on board, the cargo surveyor will issue a letter of protest on behalf of the cargo receivers and charterers, which is to be signed by the master. What is the main environmental concern during disconnection of hoses, and what action is to be ensured to mitigate it? As soon as the final stripping through the small diameter line is completed, the terminal staff will drain the cargo hoses arms, and then the disconnection will be initiated. If the draining or blowing with nitrogen is not effective, there is an immediate danger of an oil spill into the drip tray and outside it. To prevent small quantities of oil dirtying the dip tray and creating a pollution hazard from weather at sea, empty, half-cut drums should be placed under the flange when breaking it. The disconnection should be supervised by the duty deck officer until all hoses arms are off and the manifold blanks fitted. If the vessel has discharged via an SPM buoy, the disconnection operation is more demanding and, as for berthing, requires experienced hands.